I'm John McAllis, a software developer at Intel. I'm going to talk to you today about blur filters. In a previous video, I talked about Gaussian filters. While Gaussian is a good implementation, imagine that our game effect requires a large convolution kernel, and our target device is a high-resolution mobile display. Even if we reduce the image resolution, apply the blur, and then upscale the image resolution, a Gaussian filter is just too expensive. Kawase blur is a generic algorithm that gives us better performance than a Gaussian blur. A Kawase blur is a multi-pass filter where each pass applies a small amount of blur and approximates a full Gaussian filter. In each pass, the new pixel value is the average of 16 samples at varying distances from the pixel center. The distance is dependent upon the pass and the expected result. This method fully utilizes GPU sampler hardware to get 4 pixel values in one sample call. There is a trade-off in filter quality and distribution compared to Gaussian filters. While it performs better in almost all tested cases, the main impact of the Kawase filter is at larger kernels. Mobile devices tend to benefit more. Bigger GPUs need larger working textures for the difference to become obvious. A third method, called the moving averages box filter, is a simple linear time per pixel blur. It has a high fixed cost of multiple passes. This will likely mean its overhead is comparable to a Gaussian or Kawase filter for large kernel sizes. It may only apply in specific circumstances, but it is a very good tool to know just in case. The box filter replaces each pixel's value with an average of neighboring m by n pixels with all equal normalized values. One pass is done over each column or row, iterating first over the sum of the kernel size elements, with averages written to the output. Then, for each new element, the last value of the element is removed from the average, and the value to the right is added. The new average is then written to the output. When we compare the performance of a 2-pass box moving average with the Gaussian and Kawase filters, we can see that the moving box filter has a somewhat fixed cost. With the Kawase blur and the moving box average, you now have 2 more tools which you can optimize for your needs.